Welcome to lesson 2 of Extension Maths Inequalities. Today we'll be dealing with absolute value inequalities. And even though I've intended of covering only the graphical method, I ended up covering the algebraic method as well. So we'll be covering both the graphical method and the algebraic method. Alright, so what are absolute values? The absolute value of a number, x, is the distance of x from the origin. So absolute values are distances on the number line. And for example, if you have the absolute value of, x here, and the absolute value of negative x, in other words 7, right? Imagine we don't know what the absolute value of x is, but we know it's 7. Absolute value of this and absolute value of negative x, they're both the same, because the distance of 7 from the number line is the same as the distance of negative 7 from 0 on the number line. Distances can't be negative. For example, if I said to you, what is the distance of Sydney from Canberra? Let's say it's 300 kilometers. Even if I said to you the distance of Canberra from Sydney, it would still be 300 kilometers. It wouldn't be negative 300 kilometers. That doesn't make sense. Distances are positive. And mathematically, we write distances as absolute values. Okay, so mathematically, absolute value of negative 7 is the same as the absolute value of 7, and the answer to both of these is just 7, like they simplified to 7, because it can't be a negative number. Similarly, the absolute value of negative 3 is the same as the absolute value of 3, which is 3. It simplifies to 3. And so generically, absolute value of negative x is equal to the absolute value of x, which is x. Absolute values are distances from the origin, and distances can't be negative. Now, in the 3-note course, you can do most of the questions using the graphical method. It's fairly straightforward. What you do is you use algebra to rearrange the equation and make it look something like that. And when I say that, what I mean is you need to manipulate the equation so that x has a coefficient of 1. So if it's 2x, divide both sides by 2, for example, so that x has a coefficient of 1. Second thing, you need to make sure there is a negative sign here, a minus sign in between x and whatever numerical value is over there. Now you might ask, why negative? Well, think about it. When we're talking about distances on the number line, what is the distance between positive 7 and positive 5 on the number line? What is the distance between 7 and 5? The answer obviously is 2. But how did we get to? We did 7 minus 5. Why minus? I mean, that's the logical thing to do there, isn't it? 7 minus 5. And that's why we need a minus here, because we're dealing with distances, and that's why you want a minus there. Okay, so step 1, use algebra to rearrange the equation and make it look something like the following. Regardless of if it's equals, less than or equal to, greater than or equal to, regardless, you want x to have a coefficient of 1, and you need to have a minus sign here and whatever over here. Alright, and then think of the question. Once you've done that, once the equation looks like this, the inequality looks like that, then you think of it like this. The distance between x and b is a. The distance between x and b is a. Right? In this question, they're telling you the distance is a. Over here, they're saying the distance of x and b is less than a. The distance of x and b is less than a or more than a. You get the idea. The distance between x and b is more than a or is less than a. And if you just think of it like that, you'll find it's very easy. Then we plot this graphically on the number line to solve. We shade the region that is more than a, less than a, the distance is a, whatever it is. So let's look at a few examples. Before we do that, let's look at the algebra method really quickly. Now, the algebra method can be slightly confusing. There's 3 separate rules depending on the question. You have to apply the appropriate rule to solve it. So the first rule is, if you are dealing with an equation, if there is an equal sign, this is really important. If there is an equal sign, then you use the rule 1. You use the first method. The first method is you rewrite it like this. Well, what are you actually doing? You're saying the distance of 5x plus 3 from the origin is 7. The distance is 7. So it could be to the right or it could be to the left, plus 7 or minus 7, right? So we rewrite it because there's going to be two solutions, it's going to be positive 7 or negative 7, because the distance can be either. The distance will be the same, right? If you have a dot here and you have a number line, and we're saying the distance is 7, well, that is 7 units away, right? But so is this. That is also 7 units away, right? So it'll be negative, positive. That's why we write as two solutions. 5x plus 3 is equal to 7, or 5x plus 3 is equal to negative 7. So if you are dealing with an equal sign, there's going to be two solutions, and we write this, we're just going to basically make this like that, plus or minus 7, and we get rid of this sign, and that's it. That's the first thing. Like if you are dealing with an absolute value with an equal sign, you get rid of these absolute value signs and you make the right hand sign plus or minus. You write it as two separate equations, we solve each one, right? So we'll do negative 3 on both sides, simple algebra, right? And you'll get the answer. Now, why does this work? It works because the distance between 5x plus 3 and the origin can be 7 or negative 7. I kind of explained that already. Now, case 2. If you are dealing with a less than or a less than and equal to sign, either of the two, then you use this method. What do? You rewrite it as this. Now, think about it. We're saying the distance of this from the origin is less than 7. Okay, so the distance of 5x plus 3 to the origin is less than 7. So we are saying, let's say for example, we are saying that the distance of, let's say I'm traveling in a car and my distance from Sydney is less than 100 kilometers. Well, I could be on the right of Sydney or I could be on the left of Sydney, right? But I'm less than 7 kilometers away or 100 kilometers or whatever. I'm not over here somewhere. No, I am over here within this region. Right, and let's say that's Sydney. This would be plus 7, this would be minus 7, but regardless, I'm between those two values, and that's why we can write it like this. Remember, on number line, this looks something like this. We have a region between two values. Let's say that was 4 and that was negative 4, and we were asked, what is the algebraic interpretation of that? How would we write this? We would write, okay, x is less than 4 or it is more than negative 4, like this, and that's in between region. It's between those two regions, those 2 points. So that's why we can rewrite this like this. And then now remember, we are dealing with 3 equations here. So if you subtract 3 on both sides, you would write 5x. So you'd subtract 3 here, subtract 3 there, and also subtract 3 there, and you write 7 minus 3 is 4, negative 7, negative 3 is negative 10. So note how when I moved that 3, I moved it over here as well as there. Now when I divide both sides, I don't divide both sides by 5, I would divide all 3 sides by 5. I would have to divide 10 by 5, this by 5, and the 4 by 5 as well. Okay, just keep that in mind. And we'll look at a few examples just to show how it works and so on. Why does this work? Because it's less than 7. I covered that already. Now, third case is when you are dealing with a more than or a more than and equal to sign. When you're dealing with this, then you have to rewrite that equation. You get rid of this absolute value sign and you rewrite it as 5x plus 3 is more than 7, or you flip the sign and make it a negative. Alright? Only when you are dealing with absolute value in equation where it's a greater than symbol or a greater than and equal to symbol, then you have to basically rewrite this whole thing twice, and you're saying it's more than 7, or it's flip the sign, make it negative. Okay, and the reason for that is on the number line, if I said to you the distance to the origin of something is more than 3, let's just say 3 kilometers. I'm saying 3 kilometers. The distance is more than 3 kilometers away. Okay, more than 3. So it can't be here because the distance to the origin is only 1 kilometer here. It has to be more than 3 kilometers. So we're dealing with that region, and that would be x is more than 3. Or we're dealing with, let's say this is negative 3. It's more than 3 kilometers away. So again, we're dealing with that region, and that region is x is less than negative 3. Think about that for a second. Make sure you understand that, because it's important, otherwise you'll forget it. If you do maths blindly, you won't understand, you'll forget very quickly. But if you really think and understand it, then it'll all make sense and you won't forget nearly as quickly. That's why we have to rewrite that equation, more than 7 as more than 7, or it's less than negative 7, because the distance is more than 7. Alright, and we'll look at a few examples and let's see how it happens. So for each example, I'll do it first graphically and then I will do it algebraically, and you can use whichever method you prefer. Alright, so let's say that was the question. Solve the following equation. Solve the following absolute value equation. First thing we note is an equal sign. Okay, that'll be important for when we do the algebraic method. Alright, so the distance of x from 2 is 5. Okay, it's already in the form, we've already converted it, we don't need to do any conversion. X has a coefficient of 1, it is a negative sign, so we can proceed. The distance between x and 2 is 5 units. So let's plot it. We have a number line, we plot the 2. The distance of x from 2 is 5 units away. So x is 5 units away from 2, so it'll be 1, 2, 3, 4, 5. That can be x. Or x could be on the other side as well. 5 units away. 1, 2, 3, 4, 5. There we go. That's also 5 units away. That could also be x. X could equal to negative 3, or x could also be 7. Very straightforward. This is the graphical method, right? And of course I've already done it. X is 5 units away, either to the left or the right, and we say negative 3 or 7. Clearly x has to be either negative 3 or 7, and we're done. Let's look at algebraically. We are going to be using the first method, where we rewrite this. We'll do it like this. X minus 2 is equal to 5 means that x minus 2 is equal to plus or minus 5. Remember, when we're dealing with an equation, we wipe off the absolute value sign and write plus or minus. Then we'll deal with it separately. X minus 2 is 5, or x minus 2 is negative 5. Then we take 2 to the other side on both sides, and you'll get our 2 solutions. Same solution, x is 7 or x is negative 3. Same solution. Alright, check your understanding, pause the video, give that question a go. Remember to get rid of the 2 in the 2x, okay? So you want the coefficient of x to be 1. Alright, best of luck and see how you do. Alright, I'm assuming you've paused the video and given it a go. Let's check your answer. First thing, we have to get rid of the 2, divide everything by 2. So basically we divide that by 2, we divide this by 2, we divide that by 2, and that will give us 2x divided by 2 is x, 4 divided by 2 is 2, 12 divided by 2 is 12, divided by 2 is 6. Okay, now we know the distance of x from 2 is 6 units away. The distance of x from 2 is 6 units. So 2 plus 6, which gives you 8. And 2 minus 6, which gives you negative 4. The distance of x from 2 is 6 units away. X is equal to 8 or negative 4. Now, algebraically, if we were to do it, remember, wipe it off, write plus minus, right? Plus 6, minus 6, and take 2 to the outside, x is equal to 8, x is equal to negative 4. Same answer. You can do it either way, whichever way you prefer. Alright, let's look at example 2. Let's say you had something like this. Now, this is different from the previous example because we have a plus sign. Now, I did say that you need to have coefficient of x needs to be 1, which is fine, right? But that's not a negative sign, it's a plus sign. So what do we do? Well, what we're going to do is we're going to write negative, open bracket, negative 3. And if you expand that bracket, you'll find that it's x plus 3. So I haven't actually changed it, I just changed the way it looks. And we're allowed to do that because we are not changing the question. It is still the same question. This is a small trick, it's very useful, so make sure you understand what's happening. I was a plus there, I made it a minus by making it minus, open bracket, minus. Minus times minus is plus, it's still x plus 3. Anyway, the distance of x from negative 3 is 4 units. Right, plot on the number line. We start off at negative 3. The distance of x and negative 3 is 4 units away. So x is 4 units away. 1, 2, 3, 4. So it'll be there, or it will be there. Just counting 4 units to the left. 1, 2, 3, 4. Okay, and those are the solutions. Straightforward. Now let's do it algebraically. Wipe off the absolute value sign, make plus or minus 4. deal with it separately on either side. 4 minus 3 is 1, so x is equal to 1 as in our first solution, or x is equal to -7 because we take 3 over there. -4, -3 is -7. Alright, so check your understanding, see how you do. Again, make sure you have the coefficient of x equal to 1 and you need a negative sign in between. I'm assuming you paused the video and given it a go. Let's check your work. Graphically, first I have to get rid of the 3, so divide everything, divide that by 3, that by 3, that by 3, you get something like this. Then we use that negative sign trick, right? So the distance of x from -2 over 3 is 2 1/3. So I drop the number line. Here's a small trick. We drop the number line between 0 and 1. I put in 2 markers to indicate it is thirds, right? Third, 2/3, a full 1. Alright, so anyway, from -2 and 3, that would be -2 and 3, and the distance is 2 1/3. Okay, so just plotting it. Sorry, I haven't actually plotted it. So look over here. That would be 1 unit. That would be 2 units. And this would be, so that's 2 1/3. Okay, so it's a third, 2/3 full, third, 2/3 full, and a third. So 2 1/3 is here, or it could be a third, and we need 2, so it'll be there, roughly, right? You can pause the video, check the solution if you're not convinced, count it off yourself if you want, but you'll find that is the solution. So visually we can see that it's -3 or it's 1 2/3, 1 2/3 or -3. So algebraically, how we would do it? We'll wipe off the absolute value sign, make a plus or -7, deal with them separately. You need to set it out like this. Please don't do anything crazy. I've seen some students do something like this. 3x plus 2 is equal to 7 is equal to -7. You can't write it like that. 7 is not equal to -7. That's wrong. I know when we're dealing with the less than inequalities, we write it like this, but that's correct. This is just completely wrong. You cannot write it like this. There is a reason I'm setting out my work like this. Please set out your work like this as well. Alright, anyway, subtract 2 on both sides. Divide both sides by 3 and you get the 2 solutions as expected. Noting that is 2. That is 1 2/3 as in that solution there. Alright, example 3. Now let's move on to less than inequality. Solve the following inequality. Well, graphically speaking, we use algebra to rearrange. We want it in the same form as in the last few questions, right? Divide everything by 3, make that a negative. Now the distance of x from -7 on 3 is less than 1. The distance is less than 1. So let's start by plotting -7 on 3. -7 on 3 is 2 1/3. So again, 2 1/3. Now the distance of x is less than 1 from this dot here. It's less than 1 unit. So 1 unit is here, and on the left hand side it's third, 2/3. That's 1 unit there, right? The distance has to be less than that, so it's anywhere in that region. The distance of x from -7 on 3 is less than 1. It's less than 1 unit away. So it might be here, a third of a unit away, whatever. How would you draw this region? How would you describe this algebraically? Well, x less than, what is that? -1 and a third. -1 and a third. But x is more than 3 and a third. -3 and a third. 3 and a third. And that's the region. Algebraically, it would look like this. Now, algebraically, how would we solve this? When we're dealing with the less than sign, we wipe off the absolute value signs and we rewrite it in this form. Then you have 3 separate sides of this equation. And now I know this works because it's not an equal sign, because you can't have 3 equals to -3. But 3 is more than -3, so that's fine. It does work. Alright. Subtract 7 on both sides, divide both sides by 3, you get the same answer as here. So you can do it either way, whichever way you prefer. Now check your understanding, pause the video, give it a go, see how you do. I'm assuming you have paused the video. Let's check your work. So first, first thing we have to do is get rid of that. What is that? I don't know what that is. You know, I didn't really cover that. So what do? Just get rid of it. Take it to the other side. Easy, right? Now that's in a form I'm familiar with. I know what to do over here. Divide both sides by 5. Make that a negative in the middle. The distance of z from negative 3 3/5 is less than 8 1/5. Plot on the number line. You know, count 8 1/5 on either direction, and we know, count 8 1/5. So 0 will be 7 something, 7, probably something like there. Hopefully I didn't make a mistake. And 8, so it'll be 8 3/5. Hopefully again I didn't make a mistake. Oh, 8 1/5, sorry. Sorry about that, I'll do that again. It's 8, I thought it was just 8. 8 1/5. And over here it should be 7 3/5. There we go. And the distance is less than 8 1/5. It's less than that. The distance is less than that. So that whole region there, right? Sorry about that messiness. That region. How would you describe it algebraically? It's written right there. Algebraically, put it into this form. Subtract 3 on both sides. Divide both sides by 5. You get the same answer. Simplifying it to, mixed fractions. Alright, example 4. Now we are dealing with more than or equal to. Okay, so if you have a more than or equal to inequality, what do? Graphically speaking, exactly the same as before, right? We want to convert it into this form. Now, here's a small trick that you need to understand. Note that absolute value of 3 is the same as absolute value of negative 3. So what I'm going to do is I'm going to make the inside negative. Negative 28 minus x. It's the same thing, right? 3 and negative 3 is the same. I can do that. I haven't changed anything. So x minus 28. That makes it x minus 28. This is an important trick for a lot of the questions. Make sure you understand this trick. Make sure you know what I did. X minus 28. That's the form I'm more familiar with. The distance of x from 28 will be more than 12 units on either side. So we plot 28, and now you need 12 units on the right. So 28 plus 12, 30, 40. And the distance has to be more. It'll be there. And similarly, 18, 16 has to be there. Now algebraically, we write x is more than 40, or x is less than 16. Those are our solutions, and as expected, that is the answer. Now algebraically, we do have to do something. If you don't understand it, it'll look really weird. We write it like this. Is less than negative 3 or more than 3. We rewrote this as 3, then we flipped the sign, made negative, flip the sign, make negative, right? And it's just simple algebra from there. And you get the same answer. Alright, check your understanding, see how you do. Alright, hopefully you've paused the video and given it a go. You do maths by doing, not by watching Mr. Shakir do maths. Make sure you stop the video and give it a go yourself. Because you learn from mistakes, you don't learn from just nodding along. When you make a mistake, then you say, oh, that's why I made the mistake. And that's when you learn. That's when you actually learn, right? When you make a mistake. So give it a go, don't be afraid of making mistakes. Alright, so graphically, divide everything by 3 because we want to convert it into a form we're familiar with. Make it a negative with that negative trick, right? The distance of x from negative 2 is more than 4 units. So negative 2, 4 units on this side is there, 4, and 1, 2, 3, 4 is over here. The distance is more than 4, so it'll be there and there. And just describe it algebraically, and you get our solution. Now, if you do it algebraically, you have to make this more than 12, or flip the sign, make negative, right? Flip the sign and make negative. It'll be either of these two. Solving each one algebraically, fairly straightforward, and you get the answer. Here's a quick summary. You can take notes from this if you want. You can create a flashcard from this if you want. But basically, absolute value in equation. First thing you check, what is the sign? And if it's less than 11, use that method. If it's greater than, use this method. And if it's an absolute value equation, then you use this method there. So you can pause. This is a good summary. And do the homework, please. Thank you and good luck.